So in example 3, we're actually going to pull the information together and graph the polynomial function. This is part 2 of section 5.2. So our polynomial function this time is f of x is equal to x squared times x minus 3. So the very first step, according to your book, is to come in and to talk about the end behavior. To do that, we're going to look at the power function. So power function, and I will start abbreviating power function as PF just to make things a little bit quicker on all of us. So the power function is what would happen if you were to expand the polynomial or multiply it all out. Well, we would get an x squared times an x. So the power function is x to the third. That tells me that it's an odd degree in terms of the polynomial, and that tells us that the end behavior is it's going to start below and end above. And again, think about x cubed and x squared. Those are the ones to remember because we know those. So x cubed starts and stops on opposite sides. Starts and stops on opposite sides. Starts below, ends above, and the x squared starts and stops on the same side. So odd degree does this. Okay, they then want us to find the x and y intercepts of the polynomial function. This is step 2. We're going to do step 2 and step 3 together. And what I'm going to do is make a little chart of those x-intercepts. So those x-intercepts, again, are the zeros. So the first thing I'm going to do is list the x-intercept. Then I'm going to list its multiplicity. Then I'm going to come in and talk about whether it bounces or crosses. So does it cross or bounce? Each of those. And it just organizes the information for us. So the first x-intercept we'll list is 3, 0. The order we list them in does not matter because we're going to graph them correctly. So that comes from the x minus 3. Again, you're setting x minus 3 equal to 0 and solving it. Look at x equal to 3. And because we want to write it as an intercept, I'm writing it as 3, 0. Its multiplicity is its outside exponent. Well, the outside exponent is a 1. Because that is an odd multiplicity, we know the graph is going to cross. Yeah, the next x-intercept is coming from that x squared out in front. If I said x squared out in front equal to 0, I'll get 0, 0. Its multiplicity is 2. That's that exponent of the square. Because that's an even, we know the graph is going to bounce or touch, your choice of words. We still need the y-intercept. The y-intercept is going to come up to be 0, 0. I know that already because once you cross the x-axis at the origin, you have to cross the y-axis at the origin. And the other reason is if you plug x's in as 0, so if we replace this with 0 and replace this with 0, then you'll have 0 times anything, which is still 0. So we've got our y-intercept. They ask us to determine the maximum number of turning points. That's going to be the degree. So turning points. And we'll start abbreviating that as TP. So that's the degree, which is 3. That comes from this power function. Minus 1, which is 2. So at most, this will change direction 2 times. Okay, so now we're ready to graph it. Oh, let's pull all our information together. We're going to start with those intercepts. So we have an x-intercept over here at positive 3. We have another one at the origin. And that's it. All I have is 2 points. But I know the graph has to start below. So I'm going to start below. I'm going to start below on the left side in quadrant 3 and head towards that x-intercept. At that x-intercept, which is the 0, 0, we know the graph is going to bounce. So we're going to come right back down. Try not to make it too sharp of a corner. It's going to get pulled back to the next x-intercept. And the next x-intercept, the graph is going to cross. And there it is. There's our polynomial graph. Does it do what we said it was going to do? Well, it started below. It definitely ended above. Something to note that in our class, which is just basically a college algebra class, we cannot determine how high or low this thing loops down. So it could be doing this. It could be doing this. It could be doing this. I don't know. And at this point, we can't tell without actually graphing it on the calculator, which we're trying to avoid in this section. So calculus gives us the tools to find that minimum, but we don't have those tools. So we're going to leave it alone, and how far you drop down is entirely up to you. With the online homework, you may want to plot a couple more points to give you a better picture of it, but that's only with the online homework. So, our next example, same thing. They're asking us to graph the polynomial function using those same steps. And now the process will speed up because we've gone through it several times. The only thing we're really adding in is the actual graphing part of it. Example 4. In the remaining examples 4 through 7, we're going to graph the polynomial function using the 5-step process. So f of x is equal to x minus 3 quantity squared times x plus 2 times x plus 4. And there's our polynomial function. Notice it's in factored form, which is great because we can pull those zeros off really easily. Let's look at the power function first, PF for power function. If you were to multiply this all out and expand it, you would end up with an x squared times an x times an x. That gives me an x to the 4th. That tells me that the end behavior, because it is an even degree, is going to start above, it's going to end above. And we'll build our little chart of our x-intercepts, our multiplicity. And again, whether they're going to cross or bounce. So bounce or cross. So our first x-intercept is at 3, 0. It's the first one we're identifying. It may not be the first on the number line, but it's the first one we're looking at. Its multiplicity is 2. So we know the graph is going to bounce or touch. Our next x-intercept comes from that x plus 2. If you set that equal to 0, you'll get a negative 2. That has a multiplicity of 1. Because that's an odd multiplicity, we know the graph is going to cross. And finally, our last x-intercept is going to come from the x plus 4. When you set that to 0, you'll get a negative 4. It has an odd multiplicity of 1. The graph is going to cross. We also need that y-intercept. It's a really important piece of information. And to get the y-intercept, we're going to replace all those x's with all the x's with zeros. So basically what I'm going to do is rewrite the function, but leave out all the x's. So that would give me a negative 3, which we're going to square, times a 2, times a 4. And again, what we're physically doing is replacing these x's with 0, so we don't need to write them. Well, negative 3 squared is 9, times 2, times 4. That's 9 times 8, which is 72. So my y-intercept is the point 0, 72. Really high or large y-intercept. And the other thing we need is the number of turning points. So I'll squeeze that in over here. So turning points would be the degree. The degree we said was 4 minus 1, which is going to give us 3. So at most we'll change direction 3 times. Again, it doesn't have to, but at most 3 times. So if you find yourself bouncing back and forth more than that, you're in trouble. Now we can grab it. So let's see, we have negative 4, negative 2, positive. The y-intercept is 72. I'm just going to mark a point up here and call it 72. Again, with the online homework, you'll have a little bit better grid system to work with. But for this works fine. Okay, we know it's going to start above. That was what our end behavior was. So we're going to come in. We know that if these two, it's going to cross. This is the one it's going to bounce at. So we're going to come in. We're going to cross again. I don't know how low to get. I'm going to come up. I have to go back through that y-intercept. And then I'm going to bounce. So looks something like that. Again, I don't know exactly where that y-intercept comes in terms of where it catches it. So it could catch it as it comes back down. Maybe that's the top of it. Or maybe it goes through it and then comes back down. I don't know. And again, as far as we're concerned, we really don't care. You'll have to plot a couple more points to get that online graph on the online homework where it needs to be. That's the downfall of that online homework, in my opinion, is that mechanical graphing aspect to it. So, okay, let's do one more in factored form before we stop this part of the video. Still throwing my eraser around. This is example 5 on the handout. And this time we have f of x is equal to the quantity x plus 1 cubed times the quantity x plus 3. So x plus 1 quantity cubed times x plus 3. Okay, here we go through again. And what you should do is stop the video, do a step, stop the video, watch the video, then stop it and do it so that you're checking it out before we actually do it. So we're going to look at the power function. You multiply all this out, you'll end up with an x to the 4th. That's this 3 times this 1. That tells me in terms of end behavior because it's an even. It's going to start above and end above. And comes the intercepts. So the first x-intercept is at negative 1. We know that it has an odd multiplicity. That's the outside 3 is an exponent, which tells me the graph is going to cross. The next x-intercept is coming from that x plus 3. That would be a -3. It also has an odd multiplicity because it has a 1. So the graph is going to increase. The y-intercept would be 0, comma. So again, you're going to let all the x's be 0. This is 1 cubed, which is 1, times 3, which is 3. So a nice y-intercept. Finally, turning points, that's the degree of 4 minus 1, which is 3. So we'll change directions at most 3 times. That's it. And it didn't take very long to do that analysis, did it? So in terms of the picture, we have -3 on the x-axis, -1 on the x-axis, and a +3 on the y-axis. Okay. And in order to graph this, you know, it's going to start above. It's going to cross all of them. So it's going to come in and do something like that. And again, it might do some wobbling. And what I mean by wobbling is it may be doing a little bit of this down there. We don't know. So those turning points that could be happening where we're not looking at them because we don't have the tools yet to look at them. So again, you can plot more points. Hopefully you've got a graphing calculator. The way to plot more points in this case, I would be building a table using the table feature on the graphing calculator because that gives you an easy way to plot those points. So, okay, what's going to happen in the next 2 examples is it's not going to be in factored form. So let's tackle that in our next part.